In this lecture, we will conclude our closer examination of the appendicular skeletal structure, looking specifically at the foot. We'll be combining the tarsals, metatarsals, and phalanges in this opening portion of the discussion. The tarsus, what is that? Well, it's a collective designation for, in this case, 7 bones of the ankle, and these bones, of course, are called tarsal bones. The term tarsus pertains to a broad, flat surface in Latin. The talus is one of these bones, and the calcaneus, they are located on the posterior portion of the foot. The anterior part contains the cuboid, the navicular, and 3 cuneiform or wedge-shaped bones. These are composed in this case of a first or medial, a second or intermediate, and a third or lateral cuneiform. The talus, the uppermost tarsal bone, is the only bone of the foot that articulates with the fibula and the tibia. All of the others that I just mentioned do not. The talus is surrounded on one side by a medial malleolus of the tibia, and on the other side by the lateral malleolus of the fibula. During walking, the talus initially bears the entire weight of the body, very similar to what we saw when we looked at the tibia itself. About half of the weight is then transmitted to the calcaneus, and the remainder is then transmitted to the other tarsal bones. So when you think about the foot itself, one of the things you have to keep in mind is that the weight distribution is uneven, and the majority of the weight is held by that talus bone as it articulates with the tibia and fibula, hence the design of the ankle or the upper portion of the ankle. That force or that weight then is distributed as we move through the remainder of the foot, starting with the calcaneus. Let's turn our perspectives for a moment to the metatarsus and then to the phalanges. And what I'll do here is I will just give you a blown up version of the image that we had on the last slide. Study this as you're going through not only your BAS text, but also the remainder of this portion of the lecture. The metatarsus consists of 5 metatarsal bones, numbered 1 to 5. Take a look at how those are numbered. They start on that medial side, and they move to the lateral, increasing in number. Like the metacarpals of the palm of the hand, each metatarsal consists of a proximal base, a shaft, and a distal end, or head. Now, these are, again, short bones, really long bones in miniature. The metatarsals articulate proximally with the first, second, and third cuneiform bones, and with the cuboid. Review where those are. Distally, they articulate with the proximal rows of phalanges. The first metatarsal is, of course, thicker than the others because it bears more of the weight. So here too, in terms of our gait and our stance as bipeds, the weight distribution is uneven. Let's move on to the phalanges. The phalanges of the foot resemble those of the hand in number and arrangement. And William Bass will give you a couple of key pointers with regard to how to identify these when you have one in hand. Each also consists of a base, a middle portion or shaft, and a distal head. The hallux, or the big toe, has 2 large, heavy phalanges, similar to what we saw with the design of the thumb. They are called proximal and distal phalanges. The other 4 toes each have 3 phalanges. Again, proximal, middle, and distal. Take a moment to study the diagram. Now let's talk a little bit about the arches of the foot, because these are also very important and unique to the human animal. The bones of the foot are arranged into two general arches. These arches enable the foot to support the weight of the body, and they provide an ideal distribution of body weight. And this is where we see a little bit more of that distribution being uniform in nature. They distribute the body weight over a hard and soft tissue surface with regard to the foot, and they provide leverage while walking. The arches are not rigid. They yield as weight is applied, and they spring back when the weight is lifted, thus helping to absorb shocks, or in a sense allow you to deal with sudden movements, and of course the amount of leverage that it takes to bipedally locomote. The longitudinal arch has two parts to it. Both consist of tarsal and metatarsal bones arranged to form an arch from the anterior to the posterior part of the foot. The medial or inner part of the longitudinal arch originates at the calcaneus. It rises to the talus and then descends through the navicular. Take a moment to look at that. The three cuneiform bones and the heads of the three medial metatarsals are also part of this kind of inner portion of the arch. Next, we have a lateral or outer part of the longitudinal arch. This also begins at the calcaneus. It rises to the cuboid and descends to the heads of the two lateral metatarsals. The cuboid is the keystone here, or the capstone of the arch. The transverse arch is formed by the navicular, three cuneiforms, the cuboid, and the bases of the five metatarsals. So again, we recognize two major arches. We have a longitudinal arch, which is composed of a medial part and a lateral part, or an inner and an outer part. And then think about, the overall width of the foot if you were to turn this around and look at it from a superior aspect. And then there's this transverse arch formed by the navicular, the three cuneiforms, the cuboid, and the bases of the five metatarsals. And this is itemized or identified on the diagram that's in front of you. Now, in terms of clinical applications and what we can understand with regard to the shape of the foot, the human foot in this case, one of the really important aspects of the human foot is that calcaneus. Not only is it tied to both of these arch systems, but also it extends, in this case, in a posterior portion to a greater amount than what we see in any other living member of the order Primates. The idea here is that it gives us a greater plantar surface to stand on. And that is believed by many evolutionary biologists to be an important part of why bipedal stance and eventually locomotion and proficiency in those two behaviors, why that became important, and how the skeletal anatomy, specifically the appendicular skeletal anatomy, reflected that emphasis. Now back to clinical applications for a moment. In terms of what you will see in the health fields, you're going to see situations of flat-footedness. You will see situations sometimes referred to as claw-footedness. And then, of course, you'll see bunions, which are pretty common. And these three phenomena associated with the human foot are things that are pretty common in the health field. The bones that compose the arches are held together and supported by ligaments, which we'll be talking about, and tendons, along with some pretty important muscle structures. If these ligaments and tendons are weak in nature, or the height of the medial longitudinal arch, in a sense, is decreased, the result is flat-footedness. So people that will exhibit flat-footedness, sometimes it will appear as if their ankle is rolling in a medial fashion, or that will be a weak ankle. or if they were to step from a wet surface onto dry pavement, you would not see that very typical kind of impression that the foot makes, where it has this kind of gap where the arch is, the longitudinal arch exists. So flat-footedness, again, is something associated with a falling of that arch as a result of weak muscles, tendons, and ligaments. Clawfoot is a condition in which the medial longitudinal arch is abnormally elevated. It is frequently caused by a muscle imbalance that may result in this kind of hyper-expression of the arch. And then bunions, which are pretty common, this is a deformity of the great toe. And we see this quite a bit in this case, the health fields. Arthritis is very often associated with this, and arthritis in terms of the 5 digits of the foot generally will be earliest expressed and most widely expressed in that first digit. So the foot is an interesting phenomenon within the skeletal structure in the sense that it is very complex, and the shape and expression of both the transverse and longitudinal arches are important for quality of life as it relates to the foot itself. We also know that given the distribution of weight as it relates to the design of the foot, the calcaneus and the talus bones are probably the two most important with regard to this process, and are things that anthropologists and archaeologists look to understand how people are using the foot, the demands put on the foot, and of course the proficiency associated with bipedal locomotion. Let's take a look now at some of these internal structures, ligaments and muscles, and again we'll look at them very, very broadly and cherry pick out of the many muscles associated with the foot and the lower leg to be able to understand something about the biomechanical function of the foot and the demands that are placed upon it. Now, when we think about the amount of stress and strain that's put on the foot as one is running or one is walking, there are some important tendons, at least two, and then a variety of small muscles arising from the metacarpals and metatarsals that prove to be important for holding everything together and maintaining the structure of the foot as it is maneuvering or as one uses the foot. The interossei or interosseous muscles, so there's a dorsal, a palmar, and a plantar interosseous muscle structure. These are important for being able to, in a sense, plant and move as it relates to the action of the foot in walking and in running. These can be sources of potential injury when it comes to a major athletic stress that can occur or major stress that can occur on the foot itself. Now, for our purposes here and for the context of the course being an anthropological course, I'm just going to focus on two of them, which is the dorsal and the plantar interossei. The dorsal interossei, this has an origin that is associated with the metatarsals. You can kind of see where that is in the diagram itself. And then the insertion are going to be the proximal phalanges. Again, the second toe, the lateral side of the third and fourth toes. What does this do, or what is this deep muscle important to? Well, this, in a sense, will abduct toes, and it will flex the proximal phalanges. So it will abduct the toes, and it will flex the proximal phalanges. Then we have the plantar interossei. The origin for the plantar interossei will be the third, fourth, and fifth metatarsals, and then again the proximal phalanges of those same toes. What does this do? Same thing. It allows for flexion, but the additional piece is that it will adduct the third, fourth, and fifth toes. So adduct the third, fourth, and fifth toes, whereas the dorsal interossei will abduct those toes, the first and second. And again, just focus more in terms of these actions to be flexing, abducting, adducting in terms of the toe movements themselves. And then general stability, for the overall integrity of the foot. You may pause the lecture here to take a closer look at how the bones articulate and where these two interossei muscle structures attach, where they're located. Again, a lot of muscles and tendon attachments associated with the foot and its integrity. There's two that I just want to make mention of with regard to this diagram. One is kind of an intermediate layer, and then one is a superficial layer. I'll start out with the intermediate layer. The quadratus plantae muscle is important. So if you take a look at the quadratus plantae, that is going to be located generally, if you look on the right side of this diagram, generally in the middle of the foot, just below the arch. The quadratus plantae will originate with the calcaneus, and then it will insert with the tendons of the flexor muscles associated with the movement of the foot, the flexor digitorum longus, for example. But generally, what is this doing? It's flexing the second through the fifth toes, so general flexion. And again, you think about how the toes are acting as you are propelling yourself forward, that gripping piece and that kind of flexion that's occurring to move the individual forward. So that's the quadratus plantae. Then the other one that I just wanted to make mention of is the flexor digitorum brevis. The flexor digitorum brevis is a superficial muscle. It is a plantar, generally a plantar muscle structure. The calcaneus is going to be our origin again, and then the middle phalanx of the second through the fifth toes again is the insertion. This too will help to flex the second through fifth toes. Very important for general movement there of the toes and what is required to move the individual forward and really give some stability and grip from the foot surface itself. And then we have looked at the lower leg when we were examining the tibia and fibula a little bit more closely in a previous lecture. However, I wanted to revisit the lower leg for a moment just to talk a little bit about two different muscle structures um, that are important with regard to kind of the intrinsic motion or movement of the foot and ultimately and indirectly the toes themselves. The first one that I'd like to mention with regard to kind of that dorsal expression is the extensor digitorum brevis. The extensor digitorum brevis again has an origin of the calcaneus bone, and then it will insert with regard to, or in relation to a tendon associated with the extensor digitorum longus and the proximal phalanx of the great toe, so it kind of goes down and around. Find this extensor digitorum brevis for a moment on the diagram and look at where it's located. The origin's important, that binds it to, in this case, the heel, and then the tendon of that extensor digitorum longus, and then the proximal phalanx of the great toe, that, or the first digit, that kind of connects the dots there for you. What does this do? It extends the first through the fourth toes. So it allows for extension. We've been looking at flexion up to this point, but now extension, when you do the extension movement, that's going to incorporate that lower leg. Whereas a lot of the flexing is something that will be, some of it connects to the lower leg, but more on the posterior side, but a lot of it is inherent to the foot itself. And then the last one that I just wanted to highlight for these kind of broad movements or gross movements of the foot in this case is the peroneus brevis. This is a kind of a lateral expression or muscle structure that we find in the leg itself. It will have an origin associated with the lower 2/3 of the fibula, and then it will have an insertion with the base of the fifth metatarsal. So the lower 2/3 of the fibula, and the base of the fifth metatarsal, the peroneus brevis. What does this do? Again, it's more of that plantar flexion, which is important, and it will evert the foot as well. So plantar flexion, so we had extension, we have flexion now, plantar flexion, and then the extension of the foot itself, the peroneus brevis. All important muscles and important origins when it comes to the overall anatomy, skeletal anatomy of this portion of the appendicular skeletal structure, and things that are also important to what the biologist looks to with regard to the biometrics, the biomechanics, the overall functionality and size of these lower leg expressions. Remember, the unique thing about the human is that we have a very interesting orientation with regard to how the femur articulates with the pelvis, along with the overall shape of the pelvis, the location of the knees, and how they are so important in the weight bearing and the role of stance, and then the overall design of the foot with its arch, with the location size of the talus bone and the calcaneus bone as well, and then all of the surrounding muscle structures that are designed to allow for that unique bipedal locomotion. And then if we step back, the kind of bigger picture notion here as we kind of close out our look at the appendicular skeletal structure is that we have longer legs than arms, and that longer leg measure is important to our stature, but it's also important to our system of locomotion or our means of locomotion. So take this all into consideration very broadly as you're looking at not only some of the health issues associated with the foot, but also the role of the foot, its shape, its size, its overall anterior to posterior length, including the bones internal to that, how that is all designed in a way to allow us to have greater surface area, plantar surface area, and then a greater range of motion as it relates to our ability to locomote, putting one foot literally in front of the other.